Good morning, guys. Sorry for the late due to network and power connection. Uh, and now our topic is controller. First, there is a all controllers are divided into three types. First one is the hydraulic controller. It is useful for the hydraulic system. Second one is pneumatic controller. This is related to the pneumatic control system. And third one is electronics controller. But today, uh, in the modern control system, we are using normally electronics controller for total control action, and for actuating purpose we are using the pneumatic control. Before 2 or 3 class, uh, I told you that why we absolute hydraulic control system, because in a system, if there is a hydraulic control system is existing, what happens? It is leakage. It has some leakage. So say this is a biscuit factory, say it is a food processing factory, or it may cotton industry. What happens? Some leakage of fluid. It may be water, uh, it may be petroleum oil, etc. It will leakage, and due to the leakage it will destroy or damage some portion of this production. That's why we are gradually obsoleting the hydraulic control system. But till now, hydraulic control system or hydraulic controller are applicable in just like JCB, this type of machinery. They are using hydraulic control system, or somewhere it is where very much required. Then we are using hydraulic control system. Then it will coming the pneumatic control system, and then it will coming in electronics controller system. So there is a, first of all, how could I study this? We have to know, what are the components of hydraulic control system or pneumatic control system, or electronics control system. Then we go for the control strategy. There is some control strategy is there, P, I, and D, and means proportional, I for integral, and D for differential. And in practice, they are together working as PID controller. Sometimes you can listen to on some appliance, you can find there is a PID controller. So if this is a PID controller, is P, I, and D controller. So P for the proportional control action, I for integral control action, D for differential control action. Okay. So, and sometimes it is used P and I control action. Sometimes it is used only P action, but you never get any without P. You never get any controller without P and ID. You never listen I and D controller. No, it is not exist, because P is the basic part. Then we can apply I or D. But in practice, not theory, in industry, what happens? D means it is a braking, one type of braking. So D is always constant of D is always putting 0 maximum area. Okay, so this is basic concept of PID, and now gradually we are going for the control valve, control action, and then we go for the PID for each. PID for hydraulic, PID for pneumatic, PID for electronics. This is very important for your or industry or the automation, because total industry, there's a hydraulic crane, JCB, a pneumatic actuator, all are there, and ultimately electronics control action is there. So we have to know details, so that if you are interested in industry, you can find everything in this industry, and it is depends on these three types. So guys, I'm starting hydraulic control action. First, we want to give you a JCV control. Then you can understand, through this control action, you can find how hydraulic control action is working. Then I will go for hydraulic valve, and this hydraulic control action for PI and then PID. In industry, there is almost 99% cases D is not existing because D means it's a braking. You can see D means braking. So hydraulic control action. Guys, you may draw with me in your copy so that after few times you can remember this. Okay, now, this is your JCP, and we are going to study only one cylinder. You can say same things are happened here also. We can we can just control this D part by this hydraulic system. This is called D part. This is for bucket. This is control valve, and this is called piston. This is called piston, and this is rod side. This side is called rod side, and this is called head side. Here is also piston, but we don't want to show this action. Okay, here is also piston. We are talking about this portion, and this is called boom. Okay, this portion is boom. You can see here is here is the the JCB where this piston is working. If this piston is if this piston is going to this outside, then this this dipper will come in this side. If this portion is going to the inner side, then this portion this boom will dipper will going to the outer side. Okay, so how is it controlled? First, this is hydraulic control, and this is a tank, this is a tank, and this is a pump. Whenever we start this action, we always start this pump. If this this road is blocking, if this road is blocking, then it is coming inside in this way. Okay, but whenever this side is not blocking, it is open, and this is open, then pump will just show this is, if this side is blocking anyhow, if we using this control, if this side is blocking, then it is going in this way. If this side is this side is blocking, then it will go in this side, because it will giving some back pressure, it is going in this position. It is also blocking, but whenever it is open, then only it is flowing through here and it is coming here. So this is the pump, and this is the tank, and this is the MRV, this is a valve. Valve means it is one directional valve. Okay, so what happens now? You can see this is the hydraulic JCB. If this portion, this rod portion become going to the outer side, right, it is outer side due to how it is possible when the fluid, this fluid are the petroleum fluid, generally petroleum fluid which has some specific gravity, the SP, and whenever in this way, if this valve control in which channel this pump will push this liquid, push this fluid. So if in this area, if this is a this time if fluid is greater than this area, then it will create a pressure to this piston. Then piston will going to the outside. And if you get this picture, then I'm giving this example. If this portion became full of liquid, then this piston coming to the in this side, just like this, because you push this fluid over here, this is head side, this is head side, then piston will become outermost, and whenever piston is coming, it will apply some force to this dipper. Whenever this dipper getting some force, then what happens, this portion, because here is the fulcrum area, here is the fulcrum area. So what happens, this is working as a lever, it is working as a lever, because if a fulcrum area is fulcrum point is there, if you push here, then this portion will going to the up, or if you push the downward side, then it will going to the lower side. So that's why if fulcrum point is there, then what happens, piston is pushing over there. So what happens, it will coming to the near. And what happens if you push fluid through this rod side piston, then what happens, look, in this case, second case, if you push some fluid, pump is because due to this control valve, pump pump channel is connected to the rod side. So what happens, in rod side there is a lots of fluid is gathering over here, and simultaneously then the head side fluid will going to the pump, it will directed to the pump. So what happens, then this piston and this rod will going to the backward side, just like this, it will force to reach this position. And whenever this piston is going to the backward side or the rod's head side, then what happens, then it will pull this dipper, look, if it is going to the inner side, then what happens, it is because it is attached with this dipper, then what happens, the dipper will getting a pulling action to this inner side, and here is the fulcrum position is there. So what happens, if you push this direction, then this portion will coming to the outside direction, then this bucket was going to the outer. So in this action hydraulic piston is working. Now we have to know how this control action is working, because this is the control valve, this is our main topic. Because this is piston action is simple, but this control valve construction is difficult. This is called, sometimes this is called spool valve, because between this inner side there is a spool, and if you control this is called alt tilt, and this is a one type of lever, but this portion is called tiller, or sometimes it's called tilt. And then what happens, it will channelize the pump force through any one of this direction, either it will direct it to the head side, either or it will direct it to the rod side. So in this way it will contouring your hydraulic channeling. And whenever pump is connected either in this way, either connected directly here, or it will connected to this area. Okay, so at that moment it will working to channelize. But now we have to know the construction and working of this spool valve, because this is our main topic. Okay, here we control valve is working by this control valve, by this trailer or this lever. And in your automatic control system, this manual action will be removed, and it will controlled by your actuator or by your solenoid. Okay, solenoid and plunger, it will one type of actuator, it will control the position. Okay, but first time we have to know how the spool valve is working, then we can understand how it is actually work. Now we are going to the construction of this. Student, I think you all get this working principle of this portion, this piston. If anyone can understand, then ask me, I will repeat this. I just repeat this. Look, here is your piston. First, step by step. First, we have to know how the piston is working. Okay, then we go for the spool valve. After knowing this control valve action, then we will go for the automatic control action. Then automatic control action will be coming with PID. Okay, so this is your piston. This is your simple piston. Okay, whenever fluid of this side, say fluid of this side and fluid of this side are same, then piston is at this middle position, this is the neutral position. But if you push by your pump is channelized by this valve. Okay, by this valve, if you push by pump, to this fluid over here. Fluid is incoming over here, and force, it is gathering over here, it is gathering over here. Then what happens? Then it will try to push on this piston. Whenever the fluid of this head side chamber push this piston, it will coming to the outer side. Then it will coming, it will say it is coming up to this position, up to this position. This is your latest position. Okay, and it will be removed, it will be removed. So what happens if you push this piston over here? So uh, the fluid of this rod side, it must be going to the outer side. It will must be removed from over here. So it will automatically coming to the tank side. It will automatically come to the tank side. Okay, there is a two parts is there. One is tank or the reservoir, and another is pump. Okay, so pump is pushing due to your lever action of this spool valve. Pump is channelized with this, is this side. This is the head side. H side, this is the R side. So head side is gathering with this fluid. So it will push this piston. Piston is going to the outside. But what happens if you change this channel to this rod side area? So pump will be connected. Pump will be connected in this way. Pump will be connected in this way. So pump is connected to this channel, and this head side channel will be connected to the reservoir of this tank, because in the previous circuit you can see there is a spool valve, and through this valve you can use, once you can use this channel with connected with this tank, or sometime you can channel this pump with this tank. I will just explain this portion, but prior to that we have to know the piston action. So now it is connected, this channel rod side is connected with this pump, and head side is connected with this reservoir. So what happens in this position? In this position, what happens if this fluid, I am giving this another color, green color. In this way, because pump is directly connected, to the river side, rod side. So fluids are coming over here, piston in the first position, piston was in this portion. Now in this piston, it will, this fluid is try to apply some force on this piston. So what happens, piston will going to move to the inner side. It will going to move the inner side. It will come here, but this way will not block. Up to this position it will come only. In this position it will come, and fluid is entering over here. So piston will come this portion. You can see this is the new position of this piston. This is the new position of this piston, and this fluid will getting some pressure, and it will connect it to the reservoir. It will going to stag at this reservoir, and piston is, due to this pressure, piston is coming to the inner side. Whenever piston is coming to the inner side, so the rod also coming to the inner side. So this is the action of this hydraulic piston, hydraulic chamber. And now we have to know how this spool valve is working, because it is the main part by which we can channelize this pump, either this rod side, either this head side chamber. Okay, now we have to know this. Guys, if you get this point, then I will go for the spool valve working principle. Otherwise, I think, have you any confusion of this portion? Just this portion, spool valve, I will explain now. Within 2 or 3 minutes I will explain. Okay, I am going for this spool valve. This is control valve, or this is called the spool valve. If you go for the construction, I am now going for the new. Look, this is a very interesting topic of this hydraulic position of control valve. Okay, guys, if this class will dissolve, then just join the next class, because today we get two classes. Look, construction of this spool valve, or it is called control valve. This spool valve is very small, just like a one duster. If you can see the duster, just this is maybe 10 centimeter. This is maybe 3 centimeter in this way. Okay, just very small, but it is working. It is working very high part, spacious part. Okay, guys, here is the channel. Is this special channel is there? You can see this channel and this channel are the internally connected, but this channel is not internally connected. This is a separate channel. So you can see I have to segregate this. I think you can understand these things. Now it is easily understood. The channel is, what is the connection on this channel? Okay, and what are the spool look like? Okay, this is the connection of this spool, and here is the, if here is a piston, then this side is connected over here, and this side is connected over here. It is called A and this is called B. Okay, and this portion is called spool. SPOOL, spool, or it is called poppet. Okay, and this side is connected with this pump. This is pump, and this side is connected with this reservoir. Okay, this side is means reservoir. Okay, so this is the spool. How it is working? Look, just 1 minute. Now you can see okay, so it is symbolized as like this. A and B, this is pump, and this is T for tank, or you may say this is tank. Okay, so whenever this connection in this way, then A is connected with this pump and B is connected with this tank. Look, you can see in this position when symbol is just like this, then pump is connected to the channel A. So in this channel, pump is force entering, pump is forcing the fluid through this rod side. Okay, RS. And then whenever pump is flowing, then pressure will be given here. So it is from this head side, H side, HS, this fluid is coming to the B channel, and it is coming, you can see this is coming to the tank. Okay, so in this way it is circulating, fluid is circulating, and pump and tank are connected internally, but here is some valve is there. Okay, and now if this position, by this changing of this lever, we can change this position. By this changing of this position lever, if I give this position through this, so what happens, spool will coming to the here, coming to the next side. So I am drawing to the next position. Guys, I think you can understand this position. Just draw it in your book, because after dissolving this class, this all picture will going out, and then you can't understand the what is the working principle. Okay, so in this portion you can see A is connected with the this rod side chamber, and B is connected with the head side chamber when the position is in this position. Okay, means it is we are in this position, this is first position. Okay, whenever it is coming to the this side, but whenever we push this, the lever position will be in this position, say this position, red color. So it will push this piston throughout this, then it will change the position. Now how it is changing this position, I am again doing this. Okay, simultaneously if you watch this, then you can understand how it is working. And I roughly drawing this so that it is time is less. And after ending of this class, please join again to the next class.
Okay, sir.
Okay, look, only now it is few seconds time. Okay, just join. Okay, within this I am drawing this.